In this webinar, we're going to have a look at some of the surfacing techniques within SolidWorks, looking through a basic introduction to the area in the software and some of the techniques you can use to actually build up surfaces. So to actually start off and modeling this particular exercise, we're actually going to look at this mouse and actually have a look at creating it within SolidWorks and using surfaces to create some of the organic shapes within the design. So the first thing I'm going to do is just to switch to SolidWorks. I'm actually starting from a blank document to start off with, so I'm actually going to create a new part. Now in this new design, what I need to do first of all is just check that I've got the scale right, and I've measured the part beforehand. So I'm just going to do a basic sketch which is going to show how long the part is. I measured the model to be roughly about 120 millimeters, and I'm going to fix that onto the origin with a midpoint relationship, and that just helps me build up the design and make sure I've got it the right size. So now what I'm going to do is actually bring in a picture within the model. Often when you're building a normal design, a solid model within SolidWorks, it's quite easy to go in and actually measure the particular elements you want trying to design. When you're doing surface model, it's a little harder with your more organic shapes to actually measure what the item looks like. So I'm actually going to insert a sketch picture from the Sketch Tools menu. It allows me to take a picture from my machine and bring it in as a backdrop to model onto. So it's just a case of scaling this down to the right size and bringing it into position. There's panels on the left hand side where we can do this manually and also adjust the angle as well if we need to. Okay, so I'll scale this down and I'm going to move it so it's roughly in the right position so that it's approximately over that line that I created earlier on from measuring the model. So I think that's about right there. The next thing I'm going to do is to actually take away some of this white background from the picture. I can use the transparency settings on the left to do that. So I'm going to put in a user-defined transparency setting there, and that allows me to select a color and increase the transparency of that color. Increasing the matching tolerance will increase the range of colors picked up and made transparent. So with that created, I've now got that to model on top of as a backdrop. I'll just hide this first sketch. And I'm going to create a new sketch which is going to be the outline of this sketch picture that I've put in, because currently I can't model with this backdrop. But if I draw something around it, I'll then be able to use it within my design. Okay, so generally within this webinar, I'm going to be using some techniques using the spline tool in order to build up the complex shapes that I want. The spline tool is quite useful within SolidWorks because it allows us to get a constantly changing radius and quite an organic shape quite easily. It's got these drag handles which allow us to change the angle of projection of the spline, and we can increase the amount of influence by increasing the length of the drag handle. So I'll increase and put in a second spline around the top. Oops. Now what you'll notice is with this spline I'm putting in the minimum amount of points possible in order to get that shape. You'll find that you get a much better surface created if you decrease the amount of points you put throughout the spline. It helps the spline to become more free-flowing. So it's a case of adjusting those drag handles till we're getting the kind of shape we're looking for. I tend not to adjust the drag handles in the middle too much, but rather actually pull the points themselves in order to adjust the actual shape of the spline. As soon as we adjust these drag handles, again, it will make the spline a bit more unnatural. So just by adjusting the drag handles at either end, we get a nice free-flowing shape in between. Now that that's been created, I'm going to go ahead and actually exit out of this sketch. So I've got a sketch which goes all the way around the perimeter of this this profile, and I'm going to use a planar surface first of all in order to create that. So with that sketch selected, a planar surface just fills the sketch area with a particular surface model. So what we're left with is a surface body which matches perfectly the profile that we brought in from that sketch picture. Okay, so I'm actually going to bring in a second sketch picture now and do that process again. Now, rather than do it all over again, I'm actually going to open up a model that I created earlier on. So it's the same idea. I've just brought in a second sketch picture. If we hide both of those, you'll see that the sketch picture I've aligned so it's got a nice symmetry down the middle, and I've drawn out my second planar surface. We have a look at that sketch just to see how that was created. Again, that was using splines, but the only thing I've made differently here is just to make sure that I've got a horizontal relationship where it matches up with that symmetry plane, and that's just making sure that when I actually go and mirror this part when I'm finished, that it'll have nice symmetry in the middle area. There's no real point in me modeling the whole design on both sides because it is a symmetrical model, so I might as well just model half of it and then actually mirror it over. Okay, the next change to make is to actually insert a sketch which matches this silver area around the edge of the model. And that's actually flowing in several directions. It's actually flowing in sort of three directions using the X, Y, and Z axis. So it's quite a complicated curve. And in order to create that, I'm going to use a 3D sketch tool. For those of you who haven't used that before, we can find that by dropping down under the sketch to find 3D sketch. Now it's quite hard to define a 3D sketch. You might, if you've ever done it before, it's quite hard to get them right. So in order to draw this item and get it correct, I'm going to bring myself into those standard planes. By orientating myself in the top plane, for example, and limiting the amount of changes I'm making in that Y direction, as we can see in that triad on the left-hand side. So it means that I can get quite an accurate curve, but without having it going totally out of the way. Okay, so I'll start it off at this end and just draw it around, just placing points wherever the spline changes direction. And to finish the spline off, I'm just going to attach it onto the curve that I created for that planar surface first of all. Okay, so it's around about the right place from this direction. I'll now bring myself round to the right plane, and we can see the kind of sketch we've got in the other direction. So in order to bring this into the right shape, it's just a case of actually dragging these points into the right position. Okay, you'll notice it doesn't perfectly match on this end. That's just to do with the kind of sketch pictures that I've taken. Maybe there might have been a slight bit of lens distortion there. There's several reasons why it might not quite match up with those sketch pictures. So you will get a slight amount of tolerance when working with those, and it can be worth just taking a while longer, just making sure you've got them correct when you first create it. But it's not a problem. I'll just take that into account when creating my design. So now I'll switch back to this top view, just to again manipulate the shape from this direction. So it does involve a lot of switching between views in order to make sure that you're getting the correct shape. In certain areas I will have to just manipulate the drag handle in between there in order to get the correct item out that I want. And again, it's a case of actually making sure we're going to get symmetry here. So I want to make sure that this drag handle is pointing nicely with a symmetrical relationship. So I'm going to make it along X, which means that it's pointing in the X direction. So when I mirror this item over, it'll have nice symmetry on this design. Okay, so that's fairly good from this angle now. It looks quite accurate. I'll just switch back to the right plane once more just to double check that it's right still on this direction. And just to make a slight change, I'll just drag this point up a little bit and slightly adjust the drag handle in this direction. Okay, so I'm fairly pleased with that now, and you can see we've actually come out with quite a complex 3D curve. If we view it from a isometric view, for example. So we can use that for the basis of our surface model. So I'll hide these two sketch pictures out of the way now. I don't need those anymore. And in order to build up the next part of the design, I'm going to loft from about here to this end profile here. So in order to do that, I need to create a new sketch plane to draw it on. By using the control key, I can just drag out a new sketch plane into the right position. And I'll change that to a dimension of 30. Okay, so I'm just going to draw out my spline again between these 2 points. And by making sure they're in the right place, you'll see as I rotate around, I can tell that it's not passing through my 3D curve in the correct place. So if I hold the end point down and then press Control and select the 3D curve as well, I can add in a pierce relationship, which will mean that the point is exactly on this 3D curve as it passes through the sketch plane. And I'll do that the same for the bottom as well. So pierce is quite a useful relationship when working with splines, and also make sure you've got the sketch items ending in the right position. And just to finish it off, I'll just drag these drag handles out to get the kind of shape that I'm looking for. So I know it's quite rounded on this back edge, so I'm just going to pull out quite a rounded shape on here to get the right profile. So I'm fairly pleased with that, and I'm actually going to hide the sketch plane away. So I can go ahead and loft between this profile now and this one here. Now, using a surface loft is very similar to using a standard loft within SolidWorks. The only difference being is that we don't have to select an enclosed profile. We can just select a single line like this one. So I can loft from this profile here to the end profile over here. Now, the important bit about this end profile is that I've split these splines into 2 elements, so I could select them separately. We do have to make sure these green dots line up, so I just drag one to the top if it's not in the right place. And then we can select the guide curves to help influence this spline as it moves towards this end profile. So the guide curve at the bottom would be this edge, and the guide curve at the top is that 3D sketch that I created. So you'll see that we get quite a nice profile as it moves along, and it quite nicely matches the shape of the mouse. If I hit the tick, that will create the kind of loft I'm looking for. The only difference is I want to make sure it slightly undercuts a bit more around here. I do know the shape undercuts a little bit more from looking at the mouse. So I need to put in another profile at this position, I think, in order to get that, because you'll notice it's not quite matching the profile enough at that position. Now, the great thing about a loft within SolidWorks when you're working with them is that you can insert a profile straight into it. In order to do that, I'm going to create a new sketch plane at the right position. So I'm just going to drag one out to 30 in this direction this time. And that just ensures that I can get the profile in the right place. And then to insert a new profile into this loft, I just right click on it and select Add Loft Section. We can either choose to rotate and move this profile into the correct place to get a sketch where we want it, or we can select a plane within the design. So I'm going to select that new plane that I created, but you'll notice because it's below the loft, we can't select it. So we need to make some adjustments to our design tree and actually drag this plane 2 above the loft in the design tree, so that essentially it would be created before the loft. And now you can actually use it in that selection. Okay, so adding in this new sketch now, it leaves me with a new profile that I can use in this loft. So I'll just edit the sketch for that, and then I can slightly adjust the profile a little bit to make it undercut a little bit more. And we can see the profile matches a bit more nicely. So I'll just edit that loft and we can have a look at it. Okay, so that's the loft profile as it moves along. So the next thing to do is just to have a look at creating the next surface within this model. So I'll just hide this surface away, this plane away, sorry. And now I want to show one of those sketches. So that 3D sketch 1, I'm going to use that for the construction of the next surface as well. We've got quite a curved surface here, and I have to bear in mind how that will influence the next surface that we create. So it's quite an interesting thing to look at within SolidWorks. So we'll just switch back to that PowerPoint and just have a look at the types of continuity you can have between surfaces. So when two surfaces touch up to each other, we get a contact relationship, or a C0 continuity. Tangency, where a line or curve meets another curve at a tangent, we get C1 continuity. And curvature continuous, or C2 continuity, is when the curvature continues straight from one curve straight into another. And that will be done mainly with splines. So we can see, if we have zebra stripes on, what that actually looks like. So contact, you can see a visible edge between the two surfaces. With tangent, the zebra stripes follow into the next surface quite nicely, but there is, again, still a slight break in there, but it's not too bad. But then curvature, you actually can't see the break between the two surfaces. So curvature is particularly good for high quality renderings and things like that. In this particular example, we're going to go with either tangency or curvature in order to get the result we're looking for. So in order to get a tangency or curvature continuity from one surface to another, I need to be able to select something as a reference. We can actually create a sketch automatically on this plane here at an intersection by just creating an intersection curve. By selecting the front plane and this face here, I can go to the Tools menu under Sketch Tools and select Intersection Curve. Okay, and that creates a new sketch for us at that intersection. So now we can use that for the next reference. So I'm going to create a new sketch on the front plane. Sorry, the front plane there. And this again is just going to be a spline. Now I'm not fully defining these splines because it can take quite a while through this process to fully define a spline. But you can do it within your own models. It just means that this would have slightly less design intent. So if you did want to make any changes to it afterwards, it would be a little less easy to update. So I'll make the two ends coincident, and then I can add in that curvature or tangency relationship by selecting both curves. So I'll add in curvature there. Okay, so it matches up and quite nicely follows the curvature from one to another. And then I can just select the next edge. Okay, I just want to make sure that, again, I'm getting that relationship between the two edges so that it'll mirror over nicely. I want to make sure it will be symmetrical on this edge. So I'm going to add in a horizontal relationship about there. And that quite nicely brings out, quite a fluent curve from one edge to another. The next item I'm going to insert, and the next surface I'm going to create, is a boundary surface. Boundary surfaces are quite good for adding in that continuity between different areas in the model. So much like a loft, I'm selecting the profiles in one direction. So that will curve along, and then I'll select the profile down here. So we'll be essentially going across the model like that. And you'll notice that I can select a whole edge all the way along, and it doesn't seem to matter, you know, it's going to trim that back afterwards. The next thing to do is select the profiles in the second direction, which will be across the model like this. So that will be this edge up here. And at the moment, you know, it looks quite messy, but you don't have to worry about it. We can select all the edges, and it does sort itself out in the end. And we're still left with an area over here that we don't want to create within the surface. But the options within a boundary surface allow us to trim the surface back by one of the edges. So trim by direction 1 cuts the surface in half. And you can do that by direction 2 as well if you've got it going across the model like that. So the next change to make is to actually add in that curvature relationship. Without having it added in the sketch beforehand, we wouldn't be able to add that between the two surfaces. So we need to add it in to the sketches that help build up this design. And we can increase the amount of influence that curvature is bringing across through the model. The next relationship I'm going to bring on the other side, and I want to make sure that I've got symmetry across from this plane here. So we can add in a direction vector in order to make sure that the surface will be pointing in the right direction. So I'm going to use this plane here, and that will build up again that symmetry in the design. I'm not going to add in any kind of continuity in the other direction, in direction 1, because I don't really need it across the surfaces this way. So that will actually complete and create my surface now. So I get quite a nice boundary between the two surfaces. Okay, now that that's been created, I'll just hide these sketches away, get rid of them. The next thing to do is to actually create the next set of surfaces to actually finish off this shape. Now what we're left with are a set of 3-sided surfaces. As you'll notice, all the surfaces we've created so far, these two within the design, have both been 4-sided, which works quite well within SolidWorks. We do get slight problems when we're creating 3-sided surfaces, and it's just to do with the way that SolidWorks creates the surface, so it's worth having a look at that now. So, as you notice in this picture, we've got surfaces being created with what's known as UV curves, a grid that helps describe the surface. So obviously we need 4 sides to be able to construct that grid. When we get a design with, say, more or less than 4 sides, it can cause slight problems within SolidWorks. You will be able to create these surfaces, but you will get what's known as a singularity, where the curves in one direction all join up to each other. And this is known as a degenerate surface. So in order to get around this, we can use slight techniques to make sure that the surfaces we're creating are quite nice and have that underlying structure built up quite well. So we can use the trim or surface fill command in order to get a nice result out of our surfaces. And we'll have a look at how to use those now. The first one I'm going to do is just to trim this surface back to create 4 sides. Normally I'd do that just by creating a 2D sketch, but in this example I'm just going to go in and actually create a 3D sketch again to show off one of the other techniques. So when we're creating splines, we can also create what's known as a spline on surface, which allows me to draw a spline which perfectly follows the curvature of a surface, as you'll see there. So it's a real useful tool when you're creating curves within SolidWorks and you want to match them up to surfaces perfectly. So I'll create a second one now. In order to make sure I've got a nice curve on this section, I'm going to add in a long X relationship here, again for that symmetry, and just drag out this drag handle to get a nicer curve there. Okay, so I'm going to go ahead and actually trim the surface back using that edge. So I'll exit the sketch, and from the surfaces toolbar we can use the trimmed surface tool. It allows us to select a particular trim tool like this sketch, and then in the sections to remove or keep box, which is below, we can then choose the areas of the surface that we want to get rid of. Okay, so we've got a standard and a mutual trim type. Standard just lets you use a trim tool to trim one surface. Mutual allows you to trim two surfaces against each other, so it is quite a useful way of doing it. So in this particular example, I'm removing this area in purple here. And that actually means that I've created a four-sided surface from what was a three-sided gap there. So it means that when we go to create the surface, it will have nice UV curves across it to actually construct the design. The next example is using the fill command. I'm going to do that in this particular area here. At the moment, to use the fill tool, we need an edge that will go along the design and stop at the boundaries between the three edges. At the moment, these edges follow all the way along the design, and that's because these surfaces aren't joined together, they're just butting up to each other essentially. In order to join them up, we need to use the knit surface command. At the moment, we've got four surface bodies. By using the knit surface, we can turn those into one. So I'll knit the items together, and we can close any gaps that are created by slight inconsistencies in the way that surfaces are created. And that then creates one surface body. And it means that the edges here will stop where we want them to. Okay, so then I can use that filled surface tool in order to create my surface. Okay, now in here, the other thing, a good thing about it is that we can apply that continuity between the surfaces. On the two edges that I've got across here, you can see highlighting, I'm going to apply a curvature relationship which pulls the surface into position. I don't need curvature or tangency on this bottom edge. I'm going to leave it as a contact relationship. We're going to have a look at the other options in this area later on. The only thing I'm going to do is to turn on this optimize surface tick box, which is mainly used for four-sided surfaces. But then we do get a resolution control pop up. This allows us to increase the quality of the surface, but it also increases the rebuild time of the design. So you'll see that the fill surface actually creates a surface for us. We don't have to worry about going in and creating it ourselves. It does all the work for us and actually sorts out the surface itself. So it automatically creates the surface as a four-sided item and trims it back to create a nice face curves on there. Okay, so the next area I'm going to do is to create a loft in this area at the top. I'm going to open a model that I created earlier on to do that because I've already shown how to actually create a loft within SolidWorks. Okay, and it just leaves us with a design. You can see the curves created nicely across this surface. The only thing to point out is the start and end constraints that have been applied. We've got tangency to face applied on edge 1, and on edge 2 we've got a direction vector to again keep that model so it will mirror across nicely. At this point, I do want to actually create a knit surface from this. I'm actually left with 3 surface bodies once more because of the new surfaces that I've created. So I want to create one surface body out of them, and that allows me to go on and then create a solid model. So I use the knit surface command once more in order to knit these together, and I can form a solid from them now with this new tick box that has appeared. Okay, I can also merge those entities. So forming a solid is the ultimate objective of any surface model. Surfacing is a way of creating the more complex organic geometry, but you do want to create a solid model from it eventually. And by using the knit command we can do that. The other way to do it is to use the thicken command, which allows us again to create a solid model from the design if we've already got one surface body. The next thing to do is to actually mirror this item over. Before I do though, I want to create one more part of the model. If we bring back that sketch picture, we can see there's a slight concave area here where the scroll wheel is on this mouse. So I'm going to create that on the design. I'm going to actually put that in before we mirror the surface over in order to make it easier to create. So I'm going to do a new sketch on my top plane. I'm going to split this face into two. I'm adding in horizontal relationships on these curves here by dragging out those drag handles. And then I'm going to actually take away that solid body so I can see the sketch picture underneath. And then I can match up my spline a bit more accurately to that sketch picture. Okay, so I'm fairly happy with that actually. It looks like it matches up with the profile nicely. So now I can project this sketch directly onto the surface to split it into two. To do that I use the split surface tool using a split line. So I select the sketch in the top box and then I can select the face that I want to split in the second one. By having it on projected, it allows us to project the sketch onto the surface and then split it into two. Okay, I'm now at a position where I want to mirror the surface over. So I'm going to go to my features toolbar and mirror it like any other, just using the mirror tool. And I'm going to select this planar face that I created first of all as the face to mirror with. And then I'm going to mirror a body rather than a feature because it's far more robust. It means that we go in and make changes to this original design, say deleting a feature, then the mirror in the model will still be created. Okay, so that's nicely created the mouse now. It's actually looking a bit more like what we intended it to. The last thing to do is to actually create this surface. I'm going to put in some more curves in order to control the shape of it though. So I'm going to do one more sketch on here. And that's going to go from the end of that split face, okay, and join up at the top there. And I'll just adjust the profile slightly of that. Okay, just drag out those drag handles. Okay, so that gives me a curve, something close to what I'm looking for. And then I'm going to do a similar curve in the other direction. So I've already got a sketch plane I can draw on, that's sketch plane 2. And I'm going to use another spline in that direction to define that. Again, I'm going to use that pierce relationship to join it in the right place. So I'll pierce it on either side. And I'll also pierce it to that sketch that I've just created in the middle. So I've got curves which define the internal shape of that concave area, and I've got the split face which defines the external shape of it. So now I can use the surface tools again in order to create a filled surface here to match up to that. So again, in my boundary box, I just select those two edges. And using constraint curves, I can add in those two sketches that I've made. And they will help define the surface shape. Okay, so that, at this point, that would just create the surface, but it's not actually going to merge up or trim the model at all. In order to do that, I can tick the Merge Results box, and it will actually cut the design. We may have to just flip the direction by hitting this box, though. So let's see how that looks. We can see that's trimmed the model quite nicely. So the only thing left to do would just to add on a small fillet just to finish it off. Okay, so that's actually looks quite close to the design we're going for now. So hopefully that's given you a good idea of the kind of tools you can use when you're going to create a nice surface within SolidWorks, and the kind of ways that you might apply surfacing to help your design. Thanks very much for watching, and I'll just point out at this point the future webinars that we've got coming up. We've got one on the 19th of April setting up the workgroup vault. We've got one on the 26th of April performing a clean uninstall. And we've got one on the 3rd of May about an introduction to flow simulation. So again, thanks very much. And I will just stay on the line for a few minutes just for any questions that anyone's got. Okay, I've got one question here asking if there's any easy way to actually define a spline within the model. One of the best ways of doing it is actually just drawing your sketch out normally with lines and arcs, and then using the fit spline command. You'll find that under tools and spline tools. It allows you to then define your sketch normally and fit a spline around those entities. Okay, if there's no more questions, we'll end the webinar there. Thanks very much for watching.